Good morning, everyone, and thank you for joining us today. Our event on surveying large areas with VTOL drones will start now. This event is being jointly held with Quantum Systems, and we are very pleased to have Mr. Stefan Wurmser, who is the training manager at Quantum Systems, here with us today. I would also like to introduce Mr. Thomas Barucci, who is a photogrammetry specialist here at SimActive. He will be running the event today. If you have any questions, please do write them in the Q&A section and we will answer them after the demonstration. Thomas, if you'd like to start, over to you.
Thank you, Vivian. So yeah, hello everyone. I hope you're doing very well today. And thank you again, Vivian, for this very nice introduction. So welcome to this SimActive online training session. My name is Thomas Barucci, and I'm the photogrammetric workflow specialist here at SimActive for our European branch. And I'm very happy to be your host today with Stefan for this highly interesting session about how to survey large areas with vertical takeoff and landing drones. So let's start right away. What are you going to learn today in the session? So first, Stefan will talk about how to correctly plan a mission with a quantum system VTOL drone. He will then explain how to collect the optimal drone imagery and how to post-process it to get the best results possible. And I will then discuss how to perform the aerial triangulation with the PPK data in our correlator 3D software, which is the aerial triangulation is probably the most important step in the photogrammetry processing, and you'll understand why in a few minutes. Then I will talk about how to generate a DSM, so digital surface model, a DTM, and an orthomosaic with the software correlator 3D. Once the processing has been completed, we will then see how to assess the final project accuracy. And after, we will discuss how you can optimize and improve your processing workflow. And at the end of the session, we will talk about the main advantages of correlator 3D. And then with the remaining time of today's session, Stefan and I will answer a few questions you may have. Okay, so I'm going to give the microphone back to Stefan so he can start his part of the presentation.
Hello, everyone. Also from here from Germany, a warm welcome to everybody of our guests joining us this session. We say thank you for the invitation of SimActive that we can make this co-webinar together. In the beginning, a few words about our company. Quantum Systems is located in Germany, southern Germany, next to Munich. Was founded in 2015, and from the very beginning of the company, our purpose was always to build very sophisticated eVTOL fixed-wing drones. So actually, we are about 80 plus employees and still growing. One of our main points is we have a self-developed flight planning software, our self-developed autopilot software. So we are not dependent on third-party software engineering. We make it on our own, and we moved to our new headquarters almost 1 year ago. You see it in the picture. A few more words about the Trinity F90 Plus, our VTOL UAV. With an extended flight time of 90 minutes, you can fly large areas with various payloads, plug and play. I come to the payloads in the next slide. With a modular design, easy assembling, you need no screws, no tools, nothing. The Trinity is out of the box, assembled, ready to fly in less than 5 minutes. It's absolutely no problem. Intuitive mission planning with our self-developed planning software, Cubase 3D. I will show you in a few minutes how to plan a basic mission with Cubase. All our drones, our F90 Plus, are PPK ready. You can achieve a accuracy better than 2 centimeters accuracy easily. We also deliver our own GNSS base station, but you also are completely free to use other Rhinex files. You're completely free if you use your Trimble, Topcon, Leica station, what else? Also very interesting, I think, the complete package price, including PPK, planning software, drone, below $20,000. We have a high wind resistance because maybe you think, okay, with these large wings, we can just fly in calm conditions, but it's not like that. You can also fly in high wind conditions up to 12 meters per second. Easy takeoff and landing on slopes. So with this VTOL technology, you're not dependent on any catapults or what else, runways. You can take off, land wherever you want to. Also in forest areas and small streets, in urban areas, wherever you want to. And a lot of application scenarios are thinkable with this drone. So just let me show how to assemble and disassemble the Trinity. Because here you see a few pictures of the plane with different various payloads in various scenarios. Next slide. Let's have a look. On the lower right side, you see the box, the Trinity box, how it is packaged. We can easily transport it, unpack it, pack it, and carry it with you. It fits almost in every car, so you need no special equipment for carrying the Trinity drone. And it's very, as I said, very easy to assemble. You see just 7 parts, the whole drone. You need no tools, no screws, and a lot of spare parts available. For example, you crash a wing because you step on it or something else occurs, no problem. We have a lot of spare parts on stock. Just buy again, and it's in a few days you can fly again. I talked already about the robust transport case. You see here wings, main body, rear fuselage, elevator, and a battery. That's it. You just click, almost more or less plug and play, and then it's ready. One of the coolest things, as I think, with the Trinity F90 Plus is what I will show you on the next slide. You see here a huge variety of payloads, and all of them are completely integrated and completely ready to fly. You don't have to integrate anything on your own. Just plug it in, choose in the planning software the correct payload, and then you're ready to fly. All the settings are made internally. So you can choose between a high resolution EO camera like the Sony UMC R10, 20 megapixel, or even a full frame camera like the Sony RX1, that's that one. You see, completely integrated in our payload compartment. Just plug it in the Trinity, and then you can fly and take your pictures. Or we have also multispectral possibilities, all of them from the whole bunch of cameras offering microsense from the USA, like the Microsense Red Edge MX, the Red MX Dual with 10-band solution, or also the Microsense Altum. And what's very special, I think, with our fixed wing drone, with our VTOL fixed wing, is a combination between Sony UMC and the Red Edge MX in one payload. So get in one flight, you have both. You have the best of the EO world and best of the multispectral world. You can combine it. Both pictures are completely perfectly aligned, and you can use them in the software of your choice. In SimActive correlator, you can process both, like Thomas will show you in a few minutes. And also very special, actually, for a few weeks was released our Cube 240 LiDAR solution with our very high point density. You see at 100-meter altitude, you can achieve easily 50 to 100 points per square meter. A very sophisticated LiDAR solution. So let's jump to the planning software. I talked a few sentences about our Cubase self-developed planning software, planning and post-processing software. Here do the PPK process also. In the beginning, as I said, all of these sensors are completely integrated, plug and play. You just, like you see here, you choose your aircraft of your choice, like the Trinity F90 Plus, and on the right side, choose payload. You just choose the payload you want to, like here, the Sony UMC, or as I already showed you, the Sony RX1, or one of the other payloads. And coming soon is also a thermal solution. So in a few weeks, we also can offer a FLIR camera also for the Trinity. So we have all of them, EO, thermal, multispectral, LiDAR, everything you wish for your surveying. You can also fly with a link loss. So it's as I said, surveying large areas. Sometimes you're getting possibilities that you maybe because of the landscape, you lose your link. No problem, you can choose that, and the drone will follow its pre-planned ways, the points you planned before. With the Cubase software, you can make, as I said, a mission planning, as seen in the right screen or on the right picture. Make also your geotagging afterwards, including the PPK process. The next slide, I will show you how it looks like if you plan a large area with our VTOL drone, with the Trinity F90 Plus. In that case, for this planning, so we keep it as simple as possible, but all the buttons you need, but nothing else. It's not overwhelmed, the software. All the customers say it's very easy to use. After a few minutes, a few hours of clicking, of trying, you are used to it, and you can plan a proper mission. That's a mission plan for the Sony RX1, I showed you already, with an overlap of side overlap 75% and a forward overlap of 80% in 120-meter altitude. You can easily achieve area bigger than 300 hectares. So you can think if you fly higher, 150 meters or even 200 meters, what with the Sony RX1 is also an absolute problem, then you still have a resolution of some less than 5 centimeters. You can easily also achieve areas up to 500 hectares, no problem, just depending on the overlap and on the flight altitude. You see, you need just a few clicks. You need a takeoff and a landing position, and you choose your polygon, where you want to fly. You choose the flying altitude, and you choose the overlap. That's the basic settings. And of course, we have some more advanced settings. You can think of different models for the terrain following. Depending on the terrain, you can also fly cross patterns. You can also set zone elements like a no-fly zone, a working zone. So you have different possibilities. Also choose between different background maps. You can also have that's the reason, because it's called Cubase 3D. So you can also make a 3D side of it. And you see in the bottom of my screen, you're heartily welcomed. Go to our homepage, download your trial version of Cubase, and try it on your own. And then convince yourself about the easiness of the usability of the software. And then we will be happy to see you again on our web shop, for example. So now heading back to Thomas. He will now show you, after a flight of 1 hour, 1.5 hour, gathering a huge amount of data, like here 300 hectares, maybe that will be 2,000, 3,000 images, how you can process these huge amount of data with Correlator 3D. So Thomas, up to you.
Yeah, thank you, Stefan. So let me share my screen here. All right. So yeah, thank you, Stefan, for this very nice presentation. I will now talk about how to process this data in Correlator 3D. So how to perform a high accuracy drone mapping without GCPs, for instance, if you use this great PPK data. So let's start right away. So let's first talk about the optimal workflow for processing PPK UAV data in Correlator 3D. It's quite simple. Once your project has been created, you will have to extract the tie points between your image. So the software will try to find common features between all your images to build a big block of image in order to have one block at the end, and then to be able to match those images to generate some elevation data, for instance, and generate some ortho photos as well. If you want to assess the accuracy of your aerial triangulation, you will need checkpoints. So you will have to tag your checkpoints in your project and then do your bundle adjustment, which will refine the parameters of your camera and also the angle of your IMU, such as the omega phi kappa of your system. Once you have a good solution for your aerial triangulation, you'll be able to extract a surface model in a raster format or even in a point cloud, depending on your needs. From this surface model, Correlator 3D will also be able to generate a terrain model. And you can also, if you want, edit your surface models or your terrain models to refine the results. So we have like some manual editing options. Once your elevation data is good regarding your needs, you'll be able to perform the ortho rectification of all the images of your flight and then generate a seamless mosaic with all the ortho photos at the end. And you'll also be able to edit or to play with the radiometric values of your mosaic and also play with the sim lines of your mosaic if you want to refine the visual aspects of the results. Next slide. So how to perform the aerial triangulation with the PPK data in Correlator 3D. We actually have different modes to process UAV data, but for PPK, the most important thing is when you import your images in the software. So when you create your project, you have to be aware that the position that you import for each image, so each exterior orientation for the image needs to be post-processed in order to have high accuracy data, which is the case with the quantum system software. It allows you to post-process all your raw data to get the best and most accurate data as possible. So the exterior orientation that you will import will be the one that will be done after the geotagging of the image. You will also be able to play with the calibration of your sensor in order to eliminate all the radial distortion of the camera, for instance. If you want to assess the accuracy of your aerial triangulation, you will probably need to use some checkpoints, as I was mentioning. There are two different types of ground references. There is what we call the ground control point, which is traditionally used in surveys when you don't have access to PPK or RTK data. So it consists of tagging points in your image with precise coordinates, and they will be used as a reference to adjust your block of image during the bundle adjustment process. The other type of ground reference is what we call checkpoints. So the checkpoints are there not to calibrate your bundle adjustment, but they are here to validate the accuracy of your bundle adjustment. So they won't be used as reference, but they will be used to give you accuracy values for the results. And also, I will talk about interpreting the quality report specifically with a quantum system drone. So I'll talk about this in a few minutes. Let's now jump into the software and see how it works. So let me open a project here. So right now, what you see is the actual graphical user interface for Correlator 3D, which allows the user to produce the results in two different ways. Actually, we have what we call the one-click button solution, which is here also called the automated workflow. So it's generally used when you're not very familiar with the photogrammetry processing. So it allows you to generate in a one-click solution all the steps that are required in order to generate all the results you need. So if you click here, you will see that you have different profiles for your processing, and then you can also adjust the different parameters. So this is the automated workflow option, and then the other option is to go manually from one module to another. So basically, we have all the different modules here in the top bar in a sequential order. So it goes from like creating a new project to opening a project, the automated workflow I was talking about, and then you have the aerial triangulation, the DSM, DTM, and so on. If you want to learn a bit more about this automated workflow option, I suggest you to take a look at the webinar we did on this particular subject in our learning section from our website at simactive.com. So yeah, as I was mentioning, the other way to process a project is to go step by step by doing each step manually and really focus on the results you're getting out of each steps, because it's really important if you want to generate high quality data to really go step by step and really look at the output you generate in each step, because they really have an impact on the next steps that will be generated. So first, you will have to take a look at your quality reports, because it will have a great impact on the ortho rectification, but also on the DTM generation. I will show you the quality report in a few minutes. You will also want to probably edit your DTM or take a look at your at the surface elevations, because it will also have an impact on the ortho rectification, and so this is something you wanna really check if you have like any residual errors on the altimetric values. So first, I would like to talk about the aerial triangulation. If you open the aerial triangulation module here, you will see that you have like a few tools appearing on the right side. When the first step you do when you start the aerial triangulation is to extract the type points. So basically, when you create the project, what you will see is this. All your images, red dots, they appear red because you haven't processed the aerial triangulation yet. So yeah, first step would be to extract the type points by clicking this button here. You have two options here, very simple. If you want to use the optimal extraction type, it's called the standard one, which is kind of like the best solution in terms of processing time and the number of type points you can find. If you're flying over more complex surfaces, like a dense forest area, for instance, where it might be a bit more complex to find common features between the image, you might want to use the exhaustive extraction type, which will take a bit longer, but the algorithm will find more type points between the image. So once you have extracted the type points, you will see new links. Like all these links you see here. If you right-click one of these links, you will see that the software has found lots of common features between the images, even if it looks like very homogeneous on this sandy texture. If you look at one of the links here, you will see all the images that have been connected to this exact same feature here on the ground. So this is it for the type point extraction. Once you have extracted the type points, then you are ready to perform the bundle adjustment. Here in the bundle adjustment, just a few comments. We have the what we call the EO adjustment, so the adjustment of the exterior orientation parameters. If you're flying with very accurate PPK data, you want to use the direct georeferencing, which will constrain the aerial triangulation to not to play with any of the XYZ values of the image. It will just allow the software to play with the omega phi kappa angle values. The sensor calibration, you can leave it to unconstrained, but in case you want to constrain the sensor calibration for any reason, you have the option to not to adjust the focal length, for instance, or any radial or distortion parameters. So, and then if you use ground control points, which is my case here, well, actually, I'm not using ground control points. I'm using checkpoints. So if you look here on the layer tree under GCPs, you will see that I have tagged a few checkpoints, and they will be useful to assess the accuracy of my aerial triangulation. So once the aerial triangulation is completed, you will have access to this step one here in the layer tree, and then next to the step one here, you have the display the quality reports. So here, as you can see, my aerial triangulation gave me very accurate results. So by looking at the checkpoints, I can assess the average XY error, which is 1.3 centimeters here. The RMSZ error is 2.2 centimeters. So you have access to lots of different parameters here in the quality report to like double check if everything is fine and if you can move forward into your processing. Average number of type point per image here, we see that we have like a fairly big number of type points per image. We also have the average projection error, the quality assessment. This one is probably the first one you will check. You want to see like some good or excellent results here. If you scroll down, you will see that the EO adjustment has been set to direct georeferencing. So as you can see, the XYZ values are fixed. And you see that you have used your ground reference as checkpoints. So if you scroll down, this is just a visual of the type point residual error before and after the adjustment. So as you can see, all the red dots turns green for the major parts, which is considered as very good, a very good result. The image adjustment here, next section, what you see is that because we have used the direct georeferencing, the XYZ coordinates didn't move at all because they were constrained. And then the omega phi kappa, we see that by average, we have played with the omega angle by 1 degree, the phi angle by 1.8 degrees, and then the kappa by 0.9 degrees. Some image, usually on the corners on the side of the projects, might have moved a bit more for the angles, but this is not it's not a big deal. It won't affect the quality of the final results. Now we see the sensor calibration. So we see that the focal lengths, for instance, have moved a little bit. And then the software also played a bit with the distortion parameters. So you have access to all this information in case you want to deliver this report to with your results to your customers or your colleagues. The control point analysis, these are more details about your projection errors and the spatial errors. And if you look at the very last part here, you will see the detailed error for all your checkpoints. So you will see how the software has calculated the errors of the outputs using the checkpoints. And then very last page is just like a quick summary of your system information in case you want to compare different processing, different timings using different PCs, different machines. So that's it for the quality reports. So now, once you have completed your aerial triangulation, you can move on to the DSM generation. So if you exit here the aerial triangulation module, if you click here on the DSM generation, which is actually my next slide. Yeah, before I go back to the software, maybe just a few words about the DSM and DTM extraction. So yeah, as I was mentioning, once you're satisfied with your bundle adjustment, you will then be able to extract a very precise surface model and also a terrain model. So if you want to generate a surface model in Correlator 3D, well, we work in a raster format in the software. So our first output will be a surface elevation data grid that will be extracted in the GeoTIFF format. And if you want, you can also generate a point cloud at the same time. By default, Correlator 3D suggests you you generate your outputs at 5 times the ground sample distance of your image. So let's say if you have a GSD of 1 centimeter, well, the optimal resolution calculated by the software will be 5 centimeters, 5 times the GSD. However, with such data like the quantum system data, you could probably lower a bit the resolution and go maybe to down to 3 times the ground sample distance. It will add sharpness in your output and and you will really get the best quality data possible. If you go lower than 3 times the GSD, so like a pixel value, like a one-to-one matching, you will maybe add a bit more noise to your project. So we don't really suggest going below 3 times the GSD of your image for the DSM resolution. One thing that you really need to be aware is that the resolution of your DSM will have a big impact on your processing time. So you really need to ask yourself before starting your project, what is the resolution I need for my project? Do I really need something at a high resolution? Or should I go maybe with a lower resolution depending on my needs? Do I need to generate a point cloud? So basically you just ask yourself all these questions because it can make a very big difference in the processing time. So from the surface model, you'll be able to extract the digital terrain model, the DTM. So Correlator 3D has an automatic tool to extract a digital terrain model from your surface model, which look for elevation changes and try to identify elements that are not relative to the ground, such as trees, houses, buildings, cars, and things like that. Also, if you want to have more control on your results, you could do some post-processing on your terrain data or surface data to obtain better results. So if we go back into the software, let's see how it works. So when you click the DSM generation tool, it will open this DSM generation window and then just a few options there. So as I was mentioning, if you use the optimal resolution, this will be 5 times the GSD. You can refine the vertical accuracy as well, and you can go with the maximal. So basically, this is where you set your resolution. If you want to generate a point cloud, you have the option here. But again, if it's not mandatory or if it's not like an output you have to deliver, it will save you a lot of time to not to generate the point cloud. So when you click process, what you will see is something like this. So this is a very flat area, so there's not much contrast in topographical contrast, but you will see your DSM. If you want, as I was mentioning, if you want to edit the DSM, well, you can enter the DSM editing module. And then, I don't know, let's say you want to delete this, this structure here, you can simply quickly draw a polygon around and then use the delete and fill option, for instance. So this will just basically erase, taking into account the surrounding topography, it will erase the object you have selected. And of course, we keep a history of your editing here. So if you want to step back and then just get back the structure you have erased, then you can simply use the DM history. Lots of other tools in the DM editing module. Again, I am not going to go too much into details about these tools because we have covered this in some other webinars that you can access on our learning section of the website. So once the DSM has been generated, you will be able to generate the DTM. So if I exit the DSM editing mode, this button here is to extract a DTM. Again, very straightforward. You can use constraint if you, for instance, want to exclude some areas of the DTM extraction because you want to keep them exactly as they appear in the DSM, then you can draw a polygon and then use this polygon as an exclusion zone. This would be, for instance, the case if you have a stockpile maybe, and then you want to keep the stockpile in the DTM exactly as precise as possible. Because when you generate a DTM, there is a bit of topographical smoothing appearing. So you might not want to touch this stockpile, for instance, so you can exclude it. And then when you click process, what you will see is DTM, like this one here. So basically, on the DTM, you won't see any of the buildings, any of the trees. Everything has been removed. So this is the basics of how to generate a DSM DTM. You can also crop your DTM or DTM in the editing module. Oops, I clicked the DSM generation, not this guy. Here, the software is estimating the optimal resolution. Here, edit a DM. So if you draw a polygon around your DM or DTM, for instance, you can also crop if you want to get a better shape of the results. So now generating the mosaic. So now that you have generated your surface model and your terrain model, well, you'll be able to generate a mosaic from the individual orthos. So yeah, the ortho is, once you have generated your DSM DTM, you'll be able to ortho rectify either over the DTM or the DTM by using this button here to do the ortho rectification. So the first step is to generate the ortho photos, as I was mentioning. So by generating the ortho photos, you'll be able to do to ortho rectify either on your surface model or on your terrain model, depending on your need. So you'll either have a true ortho. So a true ortho is an ortho over the surface model, or just a classic DTM ortho over the DTM. And then you'll be able, once the ortho has been generated, you'll be able to create your mosaic out of this. If you have one or two images that are problematic, like if you had troubles with your lighting conditions, for instance, you can select only specific images if you want to generate a sub-part of your orthos. And you can also color balance with your mosaic. You can color balance your mosaic with your selected orthos. So you have the option to manually select and disable a few orthos depending on your project. If you want to know more about how to generate accurate ortho and mosaic with Correlator, there is a another 1 hour webinar on this topic. So if we go back into the software, if you click the ortho rectification, so if you want to do a true ortho, so an ortho over the DSM, very important, you want to first have the DSM selected in the layer tree, and then when you access the ortho rectification module, you'll be able to check the DSM-based mode. If you want to do just a standard DTM ortho, then you select the DTM, and then you uncheck the DSM based. The overlap value here, you can so by default, the software will give you the maximal overlap value, which is what we generally suggest to use to get the best, like most of the pixel information from your image. But in case, I don't know, you're flying with a 98% front overlap, which is very big, you can lower the value to 85 by manually entering the value here, for instance. You can crop your image, your orthos. I don't know if you have like some distortion on the sides. If you use a sensor with the fisheye effect, for instance, you can crop, let's say, 10% of the sides of the image to remove the distorted part and keep the most nadir undistorted area of your image. When you crop, you want to be sure that you have enough overlap so you don't create holes in the ortho. And then the resolution here, this will be the default maximal resolution of the image, so the GSD. but you can change this value if you need if you don't need like a resolution as precise as this one. You can play with the output format, and then you can compress your image. If you use the JPEG in a TIFF format, for instance, it will decrease the size of the orthos by a ratio of 10 approximately. So in case you want to save some disk space, you have this option here. And then once the orthos have been generated, you will see all the orthos stacked on top of each other. So it's not color balanced yet. Oops, let me go back into the software. It's loading the orthos. Okay, so as you can see here, we have like all the orthos stacked on top of each other. It's not color balanced yet, and it's not a seamless mosaic yet. I have access to all my orthos here in the layer tree. So as I was mentioning, if you want to disable a few orthos, you have the option here to make a multiple selection and then disable the orthos. Again, in the image folder, again, if you select a few image, you disable the image, and then when you ortho rectify, they won't be integrated into the orthos. So you can either use all of the image and then afterwards disable a few orthos from the project, or you can do it upstream right into the image folder. Once the orthos have been generated, then you're ready to create your mosaic, which is this tool here. So for the mosaic, you could tile the mosaic using a file. You can set the feathering size, and then you can use the color balancing option here. And another interesting tool is our new SimLine obstacle avoidance. So if you're flying in a very dense urban area, for instance, lots of buildings, lots of roofs, you don't want to have your SimLines crossing these elevated structures, then what you can do is select the DSM in the layer tree and then check the use loaded DEM, which will be the DSM in this case, for the SimLine obstacle avoidance. And then the software will try, when it's possible, to avoid crossing buildings and then to put the SimLines on flat areas so you don't have much SimLine editing to do on your results. And then once the mosaic has been generated, what you will see is this, a nice color balanced mosaic. So the mosaic editing, what you can do, well, what I generally do when my mosaic is completed is a few quality controls. So let me go back to the presentation. So once your mosaic has been generated, yeah, you want to assess the mosaic accuracy. So, well, you can first validate the result with the checkpoints you have used. So you'll be able to pan into your mosaic and then maybe zoom to the different checkpoints you had integrated into your project, and then see if the targets you see on the ground are aligned with the checkpoints you have used, which is this yellow double triangle here. So yeah, you can pan through the mosaic and then just quickly check, do I have like any offsets compared to the targets I have on the ground and the checkpoints I have used. So as you can see here, very accurate. The mosaic sits perfectly on the checkpoints. So even if again, the checkpoints were not used to reposition the image, the image were just like very precise. The PPK data allows to get this very centimetric accuracy on the results. So once the first visual check has been done over the mosaic, another thing you can do is to check your SimLines. So if you go into the mosaic editing module, you will see all the SimLines. So you select the block of the mosaic, you enter, for instance, the SimLine editing module. And then here you will be able to move the SimLines in case you see a SimLine crossing a structure or breaking some breaking some features. So for instance, if I go there, I take this the sim line here, yeah, across the car. This would be a good example. If you had a sim line crossing the car, like here, and then as you can see, there is a bit of an artifact here. The car seems a bit broken. So what you can do is like just select a few vertices and then move the sim line to not to cross the car and to stay on a flat surface. So that's one of the option you would have when you do your mosaic editing. And then another one is, yeah, I can, let me go back into the mosaic editing module. Another thing you could do is play with the radiometric values of the mosaic. If you go here into the adjust colors of the mosaic, you have access to the histograms of the spectral values. So you can play with the master band in case you want to play with the gamma values, just to like maybe darken or lighten the overall aspect of the mosaic, or you can go band by band if you want to refine your histograms for each band, then you can play with the values there. And it's the same when you do some changes. You can preview, check or uncheck the preview mode just to see how your modifications affect the mosaic. And then you click process, and this will save the new color adjustment values. Okay. So this covers pretty much all the topics of today's presentation. I'm going to quickly summarize what the unique benefits are from using Correlator 3D. First, we are very proud to offer an unmatched processing speed in the industry. The software is very fast. There is no any particular training required. Even if for some very complex project, we can offer processing services and training. Correlator 3D also has the automated solution with a one-click option. So once you know how to use the software, how to set your parameters, you can use this automated workflow option if you want to save time. Last but not least, there is an unlimited number of images you can process, suing a single standard PC. So that's a very big strength of the software. Finally, you have the option to batch process or to process with cloud interaction, even command line. So if you want to script and loop through different projects, there's no any problem with the software. So that's all for now. I hope this was interesting for you guys. If you have any more questions, don't hesitate, as we still have some time now, so we'll have a short question and answer session right now. So feel free to use the Q&A section of the chat and send us your questions.
Thank you, Thomas and Stefan, for this fantastic presentation. There are a few questions coming in. I think some of them are going to be for Stefan. One question from Zach: are any quantum systems UAVs capable of live video feeds, or is it just still photos?
Yeah, that's easy to answer. The Trinity I showed you today in this webinar is just with still images, as I showed, and LiDAR, multispectral EO, what I showed. But in our portfolio, we have also the vector drones. That's another drone family with a vector Scorpion. You can check on our homepage. That's capable for live video stream. So we have two different families of drones, let's say. Trinity for the pictures, and the vector Scorpion for the live video with different gimbal solutions.
Another one again from Zach. What are your basic computer hardware requirements for your flight planning and processing software? Do you require Mac or Windows systems?
We require Windows. Actually, it's just Windows, but we're working also on a Mac solution, but it will come soon. Actually, it's just Windows, but you need no special NASA supercomputer, so it's just running on almost every system. Just Windows 10 is required.
And for Correlator 3D, it's the same. We run on a Windows platform. Any standard workstation would do. We like gaming systems. Anything like an i7 or an i9 processor with a decent GPU bought over the past year or two would work just fine. Incidentally, Correlator 3D runs on standard workstations, but you can also install it on an instance on AWS or Azure, and that works just as well. Then another question from Eero. We have Einan. With PPK data, would you still recommend to adjust the height Z with GCPs? I think that's for you, Thomas.
Yeah, well, no, with PPK data, you can keep the XYZ values exactly as they were post-processed. So if you, well, basically, if you use PPK, you don't really need to include any GCPs. That's the main strength of using PPK data. And if you're using checkpoints to assess the accuracy of your results, then you don't want to play with the XYZ values of you just use the direct georeferencing. So yeah, I think I hope this answers the question.
One more for you, Thomas. Does Correlator 3D support stereo measurements of any kind?
No, we do not have any stereo option. This is a question we have a lot. It has been forwarded to the R&D team, and they are thinking about it, but I'm not sure it's something that is in the coming next release. So the current version do not support stereo.
Yes, for stereo measurements, you can always take the results of Correlator 3D and then port it into other stereo measurement software like
Yeah,
DTMs, for example, and that works
exactly.
just as well. Another one, how many workers need to operate drones in the field? This is from Shinjiro Tomozawa. I guess this is for Stefan.
Okay, for our Trinity, it's absolutely easy to operate just with one person. You don't need a second person. You pre-plan usually your mission in the office. You can adjust it to the actual conditions, wind, and so on. And then for running the drone, you have a remote control or a laptop, and that's it. And you can operate it alone. That's easy to use. I hope that answers the question.
Yes, and how is the service or maintenance handled for drones? Do you have any self-help solutions? This is from Tobias.
Yeah, we have some. We have a support that will support you in any case of something happens, and we have a lot of support videos. For example, like changing the propellers, changing the motors, and all the things that the customer can do on its own. We have prepared with tutorial videos. So there are a few points you can do on your own, but more or less with the brushless motors, the drone is more or less maintenance free. So you don't have to maintenance after several running time. The only thing you maybe sometimes have to check is the battery, if it's still running correctly, but all the drone itself is maintenance free.
Fantastic. Some more for you, Stefan. I believe that during the taking of aerial photos and drone flights automatically, but when takeoff and landing, does the drone need to be manually controlled, or can it be automatically done? This is from Shinjiro Tomizawa.
Okay, so in best case, everything is automatically. You pre-plan your mission, you check your surrounding, that there are no obstacles in your near vicinity. You can check that, and then in, let's say, 99% of the drone flights, you let it just fly automatically. But during landing, what you maybe can suggest the retransition coming back from the fixed wing mode to the copter mode, and then landing. Sometimes after 90 minutes, wind conditions changed a little bit or something, then you can adjust. You can go into assisted mode. You can correct the landing site. You're completely free to let it land on its own or correct the position. That's up to you. And it's really easy to do. It's not more complicated than with a normal copter drone.
Mm-hmm. Then there's one from Emmanuel Adiba. Cubase works with what VTOL brands? We often use DJI, and I'm wondering if this is compatible.
No, it's our own proprietary software. Cubase just works with our quantum systems drones.
And another one for you, Stefan. Can the Trinity carry magnetometers?
It has an onboard magnetometer, but you cannot adjust any other payload like a magnetometer or other possible payloads. They must be integrated. Of course, we have an internal magnetometer that it checks its position on Earth. That's obvious, but no external magnetometer.
Okay. And for Correlator 3D, there's a question about whether we have a perpetual license. Yes, you do have a perpetual license. In fact, you can purchase a permanent license. You can also rent the software on a monthly or yearly basis. So we have many modes of working with Correlator 3D. The other one was, can the software create contour lines and can that be exported into AutoCAD? Yes. With Correlator 3D, you can create contour lines from the DTM. It's a very, very quick process, and you can export them into shape files or DWGs, DXFs without a problem. That was the question. Those were the questions so far. Thomas, did you have any other questions on your side that were brought up, or Stefan?
Yeah, there's one here. What type of imagery can you process with the Correlator 3D? Well, basically pretty much any type of imagery. So regular UAV imagery. You can also process multispectral imagery. And we also have a webinar and tutorials on how to process a multispectral project. You can process thermal imagery and medium, large format, like any phase 1 or 250 megapixels. You can also process satellite imagery, and we have a scan film for the old black and white scan film. So any type of imagery can be processed with a correlator without any issue.
Okay, Stefan, did you have any questions that were asked that you'd like to pass on here?
Yeah, just an upcoming question from Rongroy Bontos. He wrote about application for solar power plant inspection. How about a thermal camera payload? As I mentioned in my part of the session, we are working on a thermal solution. It's coming soon. We're expecting it to bring it on the market on around June, July this year. So we work with FLIR together for integrating a thermal camera as well. That rounds up our portfolio from EO, multispectral, LiDAR, and thermal.
That's fantastic. All right, I think that about wraps it up, unless Thomas or Stefan, you'd like to mention anything else. Thank you all for joining us today. Please do visit our website.
I want to say,
sorry.
I want to say thank you. Thank you for the invitation from Quantum Systems. We're happy to work together with you in future. Because a drone that can fly more than 90 minutes helps nothing without a software that can also process the data in a manner that everybody can use it. So we are very thankful for inviting us. Thank you.
Absolutely. We're very pleased to have you, Stefan, and Quantum Systems work with us. And we're really looking forward to collaborating on in the near future on this. And thank you all for joining us today. Please do visit our websites. We're at www.simactive.com and www.quantumsystems.com. And we look forward to having you at our next events. Thanks very much. And thank you, Stefan. And thank you, Thomas.
Thank you, everyone.
Thank you, Thomas. Thank you, Vivian.
Speak
Goodbye, everybody.
Goodbye.